Hey everyone, you know what? There are nights when I sit back and watch the world spin, wondering where all the strange things around us truly begin. And if you are like me, carrying 1,001 questions about the mysteries of life, then come with me and let us uncover them together. Have you ever looked up at the sky and wondered why this planet, our blue, quiet-looking Earth, ended up becoming the one place where life took hold? Out of all the worlds drifting through the darkness, why did life choose this little sphere of rock and water? Tonight, we follow the first clue in that cosmic puzzle, the astonishing fact that Earth sits in what scientists call the Goldilocks zone, a place where everything is just right. Imagine the early solar system, a swirling storm of dust, ice, fire, and newborn planets carving their orbits around a young, unpredictable sun. In that chaotic ballet, each world found a place too close, too far, too scorched, too frozen. Mercury burned. Venus choked. Mars dried. But Earth somehow settled into a rare, narrow band where sunlight was gentle enough to allow oceans to form and stable enough for them to stay. This was not luck in the simple sense. It was a delicate balance, like a cosmic recipe. A little closer to the sun, and our oceans would have boiled away before life had a chance to whisper its first breath. A little farther, and the world would have been locked in eternal ice, silent and barren. But Earth found the middle point, the place where water could remain in its liquid form, the very ingredient life needs to begin any kind of story. What makes this even more mysterious is that the Goldilocks zone does not guarantee life. Many planets may lie in that zone, but only a tiny handful ever become living worlds. So why did Earth succeed where others failed? Was it timing? Was it chemistry? Or was it a chain of rare coincidences layered over billions of years? As we trace this path deeper, the question becomes even more intriguing. Did Earth choose life? Or did life choose Earth? In this episode of 1001 Curious Mysteries, we step into the first chapter of that origin story, the moment when our planet found itself in precisely the right spot in the solar system. A place warm enough to cradle oceans, cool enough to keep them from fading, and stable enough to let something extraordinary emerge from the water. A place where everything was just right. A place that might explain why we are here at all. If Earth's perfect position set the stage, then water was the first great character to enter the story. And strangely enough, no one is completely sure where all of it came from. The origin of Earth's oceans remains one of the most puzzling chapters in our planet's history, a chapter filled with cosmic ice, ancient volcanoes, and chemistry older than the sun itself. Scientists believe that Earth, in its earliest days, was far too hot to hold any liquid water. The surface was a glowing ocean of magma, and the air was thick with gas and dust. Yet somehow, a world that began as fire transformed into a planet covered by vast blue seas. How did this happen? One theory says water emerged from deep within the Earth itself. As the planet cooled, thousands of massive volcanoes released steam into the sky. Over time, that steam condensed and fell as rain, so much rain that it lasted for millions of years, slowly filling the world with the first oceans. It is a dramatic image, endless storms beating against a young, molten Earth. But there is another possibility, a colder and stranger one. Some researchers think part of Earth's water may have come from the outside, delivered by icy comets and water-rich asteroids left over from the solar system's formation. These frozen wanderers collided with Earth again and again, carrying with them the building blocks of oceans. Imagine it. Each impact planting a small seed of water, one drop at a time, across millions and millions of years. Perhaps the truth is a blend of both a partnership between Earth's deep interior and the icy messengers of space. What makes this even more mysterious is that once water arrived, everything changed. Oceans became the world's first laboratory, a place where chemistry could mix, collide, and attempt something entirely new. Without water, life would have had no stage, no shelter, and no chance. In our search for life beyond Earth, the rule is simple: find water and you might find a story. If water was the element that gave life a stage, then Earth's atmosphere was the shield that kept that stage from collapsing. And what a strange shield it is. Thin as a silk veil compared to the size of the planet, yet powerful enough to protect every ocean, every continent, and every living creature that would one day walk the land. But here's the twist. Earth did not always have this life-friendly blanket of air. In its earliest era, the atmosphere was a dangerous mix, thick with toxic gases, volcanic fumes, lightning, and heat. No oxygen. No calm blue sky. Instead, the young Earth was wrapped in a storm so violent it could have stripped away any chance of stability. And yet, something remarkable happened over millions of years. That chaotic cloud layer transformed into a protective barrier unlike any other in the solar system. What makes the atmosphere so essential to life is not just what it contains, but what it blocks. Without it, the sun's ultraviolet rays would strike the surface directly, breaking apart fragile molecules long before life had a chance to grow. Without it, tiny meteorites would rain down constantly, turning the ground into a battlefield of impacts. Without it, temperatures would swing wildly from burning heat to freezing cold in a single day, making survival nearly impossible. And at the heart of this protection lies one of the most mysterious layers, the ozone layer. Long before humans ever discovered it, long before any creature could look up and wonder about the sky, the ozone layer quietly formed and began shielding the planet from harmful radiation. A silent guardian that life never asked for but desperately needed. How did this transformation happen? Partly through volcanic gases, partly through chemical reactions triggered by sunlight, and eventually through the work of tiny early life forms that released oxygen into the atmosphere, unknowingly shaping a world they themselves depended on. A shield shaped by chaos, chemistry, and time. A shield that allowed life to take its first breath. If the atmosphere is Earth's protective veil, then the planet's magnetic field is its invisible armor, a shield we cannot see, cannot touch, but absolutely cannot live without. And the strangest part? This mighty force comes from deep inside the Earth, from a place none of us will ever visit, the molten, metallic heart of the planet. Picture the Earth's core, a sphere of swirling liquid, iron, and nickel, hotter than the surface of the sun, constantly moving and churning like a cosmic engine. As these metals flow, they create electric currents, and those currents generate a magnetic field that stretches far into space. This is the magnetosphere, a giant bubble protecting Earth from the sun's relentless stream of charged particles, the solar wind. Why does this matter for life? Because without this magnetic shield, the solar wind would strip away Earth's atmosphere molecule by molecule. It would peel our sky like an onion, leaving oceans to evaporate into space and the surface to bake under raw radiation. This is not a distant fear. It is something we have seen happen. Mars once had flowing water and a thick atmosphere, but when its magnetic field faded, the solar wind tore everything away. What remained was a silent, frozen desert. Earth avoided that fate because its core stayed alive, hot, liquid, dynamic. The movement of molten iron has been running for billions of years, never sleeping, never slowing. A hidden engine guarding life long before life even existed. The magnetosphere also creates one of the most beautiful and mysterious sights on the planet, the auroras. When solar particles collide with the shield, some slip through near the poles and paint the sky with glowing curtains of green, purple, and red. A reminder that even in protection, there is beauty. It is strange to think about. Everything alive today, every tree, every creature, every person exists because a river of molten metal beneath our feet keeps flowing in the dark. A silent guardian deep underground. A shield forged from fire, protecting a world of water and air. If Earth's magnetic shield kept danger away, then chemistry invited possibility in. And this is where the story becomes even more mysterious. Our planet was not just in the right place, it was made of the right things. The ingredients for life were already here, hidden in the dust and stone from which the earth itself was built. Every form of life we know, every plant, every cell, every heartbeat depends on a specific set of elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Scientists call them the CHNOPS elements, the basic alphabet of biology, and somehow Earth ended up with exactly the right combination in exactly the right amounts spread across oceans, continents, and atmosphere. But how did this happen? The answer lies in a time before Earth existed in the death of ancient stars. Long ago, massive stars exploded in brilliant supernovas, scattering their atoms across the galaxy. Those atoms drifted through space, mixing, cooling, and eventually gathering into a swirling cloud of dust and gas. From that cloud, the sun was born, and around it, the planets formed. Earth was built from stardust, and that stardust contained the raw materials for life. Carbon that once glowed at the heart of a star became the backbone of every organic molecule. Nitrogen from ancient stellar clouds became part of the air we breathe. Phosphorus, rare yet essential, became the spark of energy in every cell. It is almost poetic. The universe gave Earth the exact chemistry needed to build something alive. But having the ingredients was not enough. They had to move to collide, dissolve, and interact. On Earth, volcanic activity stirred minerals into the oceans, lightning split molecules apart, allowing new ones to form. Hydrothermal vents pumped heat and chemicals from deep within the planet into the dark water above. These were not gentle environments. They were chaotic, violent, unpredictable, yet perfect for the kind of chemistry that leads to life. In this chapter of the mystery, Earth was not simply lucky. It was prepared stocked with ancient elements forged in stars, waiting for the right moment to combine. The universe supplied the ingredients. Earth became the kitchen. If Earth had the right ingredients, then the next mystery is how those ingredients came together to spark something entirely new. The very first molecule capable of copying itself. This is where the story shifts from chemistry to the earliest whisper of biology. Imagine the young Earth again. Oceans stretching endlessly under a sky filled with lightning, volcanoes rumbling on every horizon, minerals dissolving into the water from deep within the crust. It was not a peaceful world, but a world full of energy, the perfect stage for strange reactions to take place. Somewhere in those ancient oceans, something remarkable happened. Simple molecules began colliding, linking, breaking, and forming again. Over millions of years, these random interactions led to more complex structures, and from this swirling chemical chaos, scientists believe one molecule emerged that changed everything. A primitive form of RNA, a molecule capable of storing information and making copies of itself. This was the moment the universe shifted. Because a molecule that can copy itself is no longer just chemistry, it is the beginning of evolution. This RNA-like structure did not think, did not breathe, did not move, but it could replicate, and sometimes those copies came with tiny differences. Some of those differences made the molecule more stable. Some made it break apart faster. And through this silent, blind process, nature began selecting which versions survived. Over time, the most resilient molecules became more common, eventually forming networks, membranes, and simple protocells. Life was still millions of years away from anything we would recognize, but the spark had been lit. What is fascinating is that scientists still debate where this moment happened. In tide pools near volcanic shores, around hydrothermal vents in the deep ocean, inside mineral pockets that acted like natural laboratories. No one knows for sure. And maybe that is what makes this chapter so haunting. Life began in a world that left almost no traces behind. But one thing is clear, the first self-replicating molecule was the ancestor of every living thing on Earth. Every tree, every creature, every person can trace their origin to that single step, a spark born from heat, water, minerals, and an ocean full of possibility. It was the universe's first attempt at life. And it worked. Once the first self-replicating molecules appeared, the universe began its longest experiment. Evolution did not rush, it did not race. It unfolded slowly, silently, across billions of years, shaping life from almost nothing into the endless forms we know today. And the most astonishing part, it all began with simplicity. In the earliest oceans, those primitive molecules gradually learned how to protect themselves, how to use energy, and how to build membranes. These fragile structures eventually became the first true cells, tiny bubbles of life floating through a vast, ancient sea. They could absorb nutrients, divide, and adapt. They were not complex, but they were alive. For nearly 2 billion years, life remained microscopic. No forests, no animals, no creatures swimming or crawling, just colonies of single-celled organisms, breathing slowly under a dim blue sky. But while nothing dramatic happened on the surface, deep inside, life was experimenting. Cells began working together. Some formed partnerships. Some swallowed others, forming the first complex cells with internal structures. This quiet revolution eventually led to multicellular life, something that had never existed before. Suddenly, organisms could grow larger, move differently, and explore new environments. Simple bodies evolved into more coordinated shapes. Tiny worms, soft-bodied creatures, sponges, and early sea organisms drifting through ancient oceans. Then came one of the most dramatic moments in Earth's history, the Cambrian explosion. Around 540 million years ago, life burst into complexity. Skeletons, shells, eyes, legs. Entire new ecosystems emerged almost overnight in geological time. Evolution had discovered creativity. From there, the story accelerated. Fish filled the oceans. Plants colonized the land. Some creatures developed lungs. Others developed scales, feathers, or fur. Life spread across every corner of the planet, swamps, deserts, mountains, frozen seas. And every new form, every new adaptation traced back to that ancient molecule in the early oceans. Eventually, some descendants of fish crawled onto land, giving rise to reptiles, birds, mammals, and much later, humans. All of it shaped by natural selection, small changes accumulating over unimaginable stretches of time. Evolution was not just a biological process. It was the universe learning to build complexity, one tiny experiment at a time. If evolution is the story of life growing and changing, then Earth's catastrophes are the moments that tested life to its limits. And strangely enough, these disasters did not end the story. They pushed it forward. Every time the planet was shaken, scorched, or frozen, life did not just survive. It reinvented itself. Throughout Earth's history, there have been at least 5 major mass extinctions events, so dramatic that they erased most of the species living at the time. Entire ecosystems disappeared. Oceans emptied. Forests collapsed. The planet fell silent, but never for long. One of the earliest catastrophes was the Great Oxygenation Event, when tiny organisms began releasing oxygen into the atmosphere. It sounds harmless now, but at the time, oxygen was toxic to many ancient forms of life. Entire microbial worlds vanished. Yet this disaster eventually created an atmosphere that allowed complex life to flourish. Later, volcanic eruptions reshaped continents and filled the sky with dust. Ice ages marched across the planet, freezing oceans and locking animals into struggle. Shifts in climate forced species to adapt or disappear. And then there were the asteroid impacts, sudden, violent events that changed everything in an instant. The most famous impact happened 66 million years ago, ending the reign of the dinosaurs. A fiery explosion, global darkness, collapsing food chains, life seemed doomed. But in the shadows of that destruction, new possibilities emerged. Mammals expanded, forests transformed, and eventually humans appeared. Catastrophes were not interruptions to life's journey. They were catalysts. Each extinction cleared space for something new. Each collapse gave evolution a chance to try again, to experiment with shapes, behaviors, and ideas that had never existed before. Life on Earth became more complex, not despite these disasters, but partly because of them. In the strange rhythm of our planet, destruction and creation move hand in hand. And every living creature today, including us, is the result of billions of years of resilience, adaptation, and recovery. Life survived fire, ice, darkness, and impact. And with every trial, it grew stronger. If Earth's atmosphere and magnetic field protected life, then the moon did something even more subtle. It kept life possible by stabilizing the world beneath our feet. Without the moon, Earth's story would look very different, maybe too chaotic for life to ever take hold. It is easy to forget how strange our moon really is. Compared to the size of its planet, it is enormous, far larger than the moons of Mars, Jupiter, or Saturn relative to their hosts. Its creation was violent. A Mars-sized object struck the young Earth, sending molten debris into orbit. Those glowing fragments eventually gathered, cooled, and became the moon we know today. Out of destruction came a companion that reshaped Earth forever. The moon's most important job is stabilizing Earth's axial tilt, the angle at which our planet leans as it spins. Without the moon, that tilt would wobble wildly over millions of years. Seasons would shift into extremes. Imagine centuries of burning heat, followed by ages of freezing cold. Oceans would expand and retreat unpredictably. Climate chaos would be the norm, not the exception. But with the moon's steady gravitational pull, Earth's tilt remains fairly stable, swaying gently like a slow breath. This stability creates consistent seasons, predictable temperatures, and long periods of environmental calm, the perfect conditions for life to evolve, diversify, and flourish. The moon also shapes the tides, pulling the oceans back and forth each day. These tides created coastal zones where early life could move between water and land. Some scientists believe that without tides, the first steps onto land might never have happened. And there is something else, something more poetic. The moon's soft glow transformed Earth's nights, allowing early creatures to navigate, hunt, migrate, and eventually dream under its light. It became a quiet partner in life's unfolding story. A world with no moon would be unstable, unpredictable, and harsh. A world with a moon became home. The moon does not just orbit Earth. It shapes Earth and every life form that has ever lived here. Even after everything we have explored, the perfect distance from the sun, the oceans, the atmosphere, the magnetic shield, the chemistry, the long chain of evolution, there's one more piece to the puzzle. And it might be the most mysterious of all: luck. Cosmic luck. The kind that does not follow formulas or equations, but emerges from the quiet randomness of the universe. Because when we step back and compare Earth to the billions of planets scattered across the galaxy, something becomes clear. Very few worlds end up like ours. Some are too hot, scorched by their stars. Some are too cold, drifting through eternal darkness. Many have no atmosphere, no water, or no stable climate. Even when planets fall within the so-called habitable zone, most never develop the chain of conditions needed for life to begin. Earth somehow did. Maybe it was not just one stroke of luck, but 1,000 small chances stacking together across billions of years. A collision that created the moon at exactly the right angle, volcanoes releasing just the right gases, comets delivering water instead of destroying everything, a magnetic core that stayed molten, a climate that calmed itself, a molecule that learned to copy its own shape. At any point, the story could have broken, but it did not. And here's where the mystery deepens. We still do not know how rare life actually is. Maybe there are thousands of living worlds out there, each following its own path. Or maybe Earth is one of the very few places where everything aligned perfectly: the right place, the right chemicals, the right history, the right timing. From this perspective, Life feels less like an inevitability and more like a delicate balance, a cosmic coincidence that turned a ball of rock into a planet that breathes, grows, and dreams. And when you look at Earth through that lens, you begin to realize something profound. We are the result of a universe that rolled the dice and landed on a miracle, a fragile, shimmering oasis floating in the dark, a rare world in an endless sea of possibilities. When we gather all these pieces, the perfect orbit, the early oceans, the protective skies, the magnetic shield, the stardust chemistry, the first self-replicating molecules, evolution's long journey, the planet-shaping catastrophes, the moon's steady guidance, and the quiet luck of the universe, a picture begins to form. Earth is not just a planet that supports life. It is a planet sculpted for life through billions of years of balance, chaos, and chance. Every mountain, every drop of water, every creature, every breath you and I take, all of it traces back to those ancient conditions that aligned long before humans existed. We are living in the outcome of a cosmic story still unfolding, still mysterious, still filled with questions that invite us to look up and wonder. And maybe that is what makes Earth so extraordinary. Not just that life appeared here, but that it stayed, grew, and began asking where it came from in the first place. In the end, the greatest mystery may not be how life began, but how many more secrets this planet still holds. And if you carry the same questions I do, feel free to leave a comment, and in the next part, if you subscribe to the channel, we will dive even deeper together and uncover everything step by step. And if you enjoy journeys like this, do not forget to like and share so more curious minds can join us.